Hey guys, so today we're going to do 4.5 applications of exponentials and logs. Okay, so one thing I really want you to focus on while you're doing this is look at the vocabulary that shows you which equation to use. Okay, now of course in these notes you might see right here it says note this is on your reference sheet. I will eventually print you out a reference sheet, but you cannot use that on your test or quizzes. So really, as much as it might say here, note this is on your reference sheet, I would just highlight it that, hey, I need to start memorizing this and picking up where I'm supposed to use it, okay? So what is given to us? What formula do we use? And then we solve it, and what strategies do we solve it, okay? So compound interest. By the way, a lot of these formulas help you predict money, population, all that stuff. So it's really useful. If a principal amount of P dollars is invested in an account earning interest at an annual rate, R, compounded N times a year, the amount A in the account after T years is this equation right here. Okay, so what I want you to notice is that one, it's compounded, and then it tells you how many times a year, and that changes all the time. Annually is 1, monthly is 12, so on and so on. Semi-annually, twice. Okay, so we need to pick up on that vocab. So the other thing you need to remember is to convert your percentage to decimal. So remember that's 2 decimal places. So as I read, I'm going to start putting and labeling them as my principal, my rate, my N per year, or my amount, or T for years, okay? So suppose $2,000 is invested. So that's what I put in. So that's my principal. Into account earning 3%. So my rate is 0.03. Move it over twice, right? And it's compounded monthly. That means my N equals 12 because there's 12 months in a year. How much will the amount be in the account after 6 years? So what I'm going to do is I'm going to write my equation, okay? I'll write it at the top here. We get A equals 2,000 times 1 plus 0.03 over 12 to the 12t. This is the original formula according to the situation. Now I'm going to answer questions by plugging in, okay? So this is how much will the amount. So what are we solving for here? We're solving for A, knowing that T equals 6. Okay, so I'm going to write that down what that means. So we get A equals 2,000 times 1 plus 0.03 over 12 to the 12 times 6. Okay, now I'm going to show you how to put that in your calculator. Okay, I know that I have a bigger screen and everything, but considering you do not have graphing calculators, you want to do this in a certain order. Okay, the first thing I would always do is work inside out. So I have 0.03 divided by 12. Now, next would be my 1 plus that. So I get 1 plus 0.0025. Now I'm going to carry it to the exponent, right? Now, I'm just going to do this so I'm not doing calculations in my head. It's 12 times 6. Enter. Okay, and I get this huge number. And then I'm going to multiply it by 2,000. Okay. Now let's keep in mind that this is an amount and we're approximating. This is the amount in dollars. So that's $2,393.90 when we round. Okay. Ta-da! Okay, next one. How long will it take? So in other words, we're solving for the time, knowing that our A is going to be 3,500. Okay, so let's write down what that looks like. That means we have 3,500 equals 2,000 times 1 plus 0.03 over 12 to the 12t. Okay, here what we're going to want to do, and of course I didn't leave myself much space because why would I do that? I have to do some solving. I'm not going to put this in my calculator and work backwards because that's where I can make my most mistakes. So I'm wanting to solve for t, and then I'll put that into the calculator. Okay, so first thing I'm going to do is divide both sides by 2,000. When I do that, I get 1.75 equals, and the other thing I'm going to do is I can do this on my calculator, right, and plug that in, as long as it's not a huge repeating decimal, and we know it's not because it's 1.0025. That makes my calculations a little bit better. Now, let's remember from a little couple sections ago, when we're dealing with time and growth, and we're dealing with an exponent, right? We need to use ln. Remember, time and growth means we use ln, the natural log. So I need to get t into a base instead of an exponent. So to do that, I ln both sides. Now, of course, ln is not the base itself. I know this looks like an exponent, but it's because I'm running out of space. So what I have right now is I have ln of 1.75 equals ln of 1.0025. Okay, now of course this would be to the 12t, right? But what do we know what we can do with that exponent? We can put it in front. Do you guys remember exponent rules with ln and logs? We can put that in front. Now this is a multiplication, which means to get t by itself, I can take this ln of 1.75 and divide it by 12 ln of 1.0025. Now, if it wants the exact answer, I can keep that as is, but we're going to estimate how long it takes. When you put this in your calculator, guys, make sure that, just in case, so there should be a parenthesis around here, and then when you do that division, make sure there's an extra parenthesis around here, so the whole thing is divided by the 12 ln. Okay, so when we get that, we get 18.68. Now remember, this is a situation, so we do need our units, which this would be years. Perfect. Okay, great thing is we're still dealing with the same problem, right? How long will it take the principal of 2,000 to double? So this is a little bit different, right? This is still our P, but double means the A has to be double that, which is 4,000, okay? And we're solving for T, which means, let me set this up. We have 4,000 equals 2,000 times, I'm just going to put the 1.0025 in there because we know that from the problem before, 12t. Okay. Now I'm not going to do all the steps. It's the same steps as B here, but if you do that out, you can pause right now and see if you can get the same answer. I come up with that t equals ln 2 all over 12 ln 1.0025. Okay, which, if you do that on your calculator correctly, you get 23.13 years. And guys, this is so useful because if you're wanting to invest money, you're able to do that knowing, because from a bank and what my husband does for a living and everything, they have a certain rate they go by, and you can then predict how much money you actually have to put in before and how much long it takes to do that. Because if you're wanting to buy a certain car in a certain amount of time, you have to figure out how much money you have to put down or save up before you can go on to that. Does that make sense? This is all real life stuff. I love it. Okay. Suppose we want to invest $10,000 and hope to have $15,000. So $10,000 is our principal. We hope to have, that's our A, in 8 years. So that's our time. What interest rate, compound annually, so n equals 1, must we seek to achieve? And this is what your parents do all the time when buying a house. Well, of course, you always want the lowest rate possible, but you have to calculate how your mortgage would be and how much you have to owe in the long period of time based on the rate that's given to you. So if we had this goal of investing $10,000 and wanting $15,000 in 8 years, we need to figure out what's a great rate for us to try to invest this at. Okay, so let's look at what this looks like. So our A is 15 equals, and it's our principal times 1 plus our rate is what we're questioning. Our n is 1, and then we have 8 years, right? And it's 8 times n, which is 1. I'll just put that in there for you guys to remember the n is there. Okay, now we have to do some solving, and this gets a little tricky, right? Let's try to do as much as we can without a calculator before we need to use it, okay? So I'm going to divide both sides by 10,000. I get 1.5 equals, and I get this 1 plus r to the 8. Okay, everybody see how I did that? How do you get rid of an 8th power? Well, that's the 8th root, right? So I'm taking the 8th root of both sides. Again, I'm not going to plug it into my calculator until the very last moment because I do not want us to start estimating within a problem, okay? So then I'm going to subtract 1 from both sides. So I get r equals the square root of 8, the 8th root of 1.5 minus 1. Now we can do that in our calculator. We end up getting approximately 0.0519. I'm going out long. This is why. Because you would never say 0.0519. We have to change that back into a percent, right? Because that's our unit, is a percent. So that means we move it over twice and we get 5.2%. Ta-da! All right, so now what happens? Well, what if it says continuously? If a principal amount of P dollars is invested in an amount earning interest at an annual rate R, compounded continuously, the total accumulation after T years is P per, my students tend to say per in the very end. So remember what it means, it's like compounding almost every minute, every day, every second. It just keeps going and going and going. So that's why we do the E function, okay? So what's very good to look at is it will say continuously, okay? Suppose you invest your first annual bonus of $4,000. So of course that would be your P. in a retirement account. So this is what happens, guys, which promises a minimum of 5% interest. Let's remember that I'm going to change that to 0.05 for R. It's compounded continuously, so that tells me I'm using this equation, not the one we did on the other side. How long will it take? So that's we're trying to find T. To triple our value. Well, triple our value means that A equals, let's see, 4,000 times 3 is 12,000. Okay, see how I'm able to do that all at once and identify each number with each variable. All right, so let's set this up. So we have 12,000 equals 4,000 E, now R to the R, which is 0.05 T. Awesome. Now we're going to solve, right? Let's move this over so we get 3 equals E to the 0.05 T. Well, how do we get rid of E? We have to ln both sides. And that cancels that. So we have ln 3 equals 0.05 T. And that means T equals ln 3 all over 0.05. Do that in on our calculator, and we end up with 21.97 years. So almost 22 years to triple your money. Now, just to tell you, that's if we only did the 4,000 bonus and we did not add anything else into it. That's why a lot of people, when they invest, you want to continue investing more into your retirement account every year, so you're building that interest on more and more and more money. Because if we just put the $4,000 in, gosh, it took 22 years just to triple that. I don't know about you, but 12 grand is not enough to live on after retirement. Okay, so you got to keep investing every year. Gosh, I'm giving you financial advice. It's a good thing my husband knows what he's doing. Okay, ready? This one, exponential growth and decay. Suppose a substance grows or decays exponentially as a function of a variable time that represents T, of course, T in time, and its amount of time is A of T. So the amount of time, A subset 0 is the initial, K is the rate, okay? So if K is greater than 0, it goes exponentially. If K is less than 0, it decays, okay? So we got to pick this up. There are going to be a few tricks with this. Another thing you want to keep in mind is, what is the question actually asking me to do, okay? In order to perform I'm not good with this, guys. Research. Cells are harvested from discarded umbilical tissues and grown in a laboratory. A technician observes that a culture of 12,000, so that is our initial, right? Our initial is 12,000, grows to 5,000. Okay, so that is an A of 1 week, which is A of 7. And that means T equals 7. Assuming that the cells grow exponentially, so what that means is it's growing. So I'm hoping that when we find our K, because as you can see from the rest of the sentence, we don't know what our K is. Okay? We want to find a formula. So 2 things. It's growing exponentially, so when we find K, it needs to be greater than 0. Check 1. Check 2 is that the actual question is asking for the formula. So the idea is this, guys. We want this equation, and we want A subset 0 to be filled in. We want K to be filled in, and T to be the variable. Okay? T to be the variable. All right, so we need to find K. So here's a couple things I want to show you. Now, you can use 12,000 or you can use 5 million, or we can cut that down. That's up to you. I would be careful on your zeros though. So if I say, let's do this in thousands. So we have T is 7, your A subset 0 is 12,000. Let's do that as 12. So we're going to count in thousands. And that means that A subset, or A of T, which is of 7, equals 5,000. Okay, think of this. I took away 3 zeros, so I'm going to take away 3 zeros from the 5 million. That just cuts down writing and making sure I don't miss zeros. Okay, so let's keep in mind that this is in thousands. Okay, now let's set this up. We have 5,000 equals 12E. K is what we're looking for in 7 days. Okay, now why is it that I didn't use 1 for T? Because it says here that T is days. So let's keep that in mind. That is why I'm using 7, not 1, because it says days. Now I'm going to solve for K, okay, just like we normally do. So I'm not going to use my calculator as much as possible, so that way I can be more accurate in my answer. So L on both sides. Equals 7K. So K equals ln 5,000 all over 12. That's inside there, all over 7. Now, there's a couple ways that we could do this. Some answers will be okay with you putting in decimals. Some need that in the equation, okay? We're actually going to change this to a decimal and go up 4 decimal places. So when I do that, I get 0.8618, okay? Now, remember, the ultimate goal was A of T. So that means our actual formula, see, we started with 12 because it's in thousands, and I didn't put 12,000 down because it says it wants it in thousands, so I'm going to put 12 down, E, and then we don't know the time, we use the time, the week, to allow us to know that K was 0.8618. And now we can use a formula to figure out any situation of the population over a certain amount of time. Okay. All right, let's do some more of this, see if we can get down. Iodine 131 is commonly used radioactive isotope that helps detect how well the thyroid is functioning. Well, this is all medical now. Iodine 131 decays, so remember that means that our K is going to be less than 0. And after approximately 8 days, 1/2 of its original amount remains. If 5 grams of iodine 131 is present initially, find a function gives the amount. Okay, so again, we're looking at a function. We have that the initial is 5 grams. We also know that after 8 days, it is half the amount. You guys see where I'm getting that? So 8 days is our T. This is days, okay? And we want the function. So what are we missing? We're missing K. So we have to find K before we can give our function for all of this. All right, what does that mean? That means that 2.5 equals 5 times E to the 8k, right? I'm going to solve. I get 1/2 equals e to the 8k. ln both sides, so we get ln 1/2 or 0.5, guys, if you want to do it that way, equals 8k. So k equals ln 1/2 over 8. I'm going to approximate that out so we can test that it's a decay. When we plug that in our calculator, we get negative 0.08664. Test that out on your calculator to make sure that's what you've gotten. Okay, it's decay, so that's great. It's negative. Now, what was the initial thing that we needed to solve in the end? We needed a function. So a of t equals, our initial is 5, e to the negative 0.08664 t. All right, there we go. If the half-life of iodine 131 is approximately 8 days, so there's a connection between these two guys, right? If 5 grams, so it's the same problem, of iodine is presented initially, how many days will it take? Okay, so in this case, the purpose of this is that we are using the equation we just got up here to help us figure out how much time it will be to get to 0.625. So I know that we want our a of t to equal 0.625. We know we started out with 5, e, and now we know our k, which is negative 0.08664 t, and we're solving for t. All right, again, I'm not going to do any calculation until I get to where I'm not estimating. Okay, divide both sides by 5, right? That gets rid of that. How do you get rid of the e? We ln both sides, giving us negative 0.08664 t. Divide both sides by that, and we get t equals. So I want you guys to try to calculate that out to make sure. And remember, this is an approximation, and you should get 24. Try that out. Pause the video, try that out. Make sure your parentheses are in the right place, okay? And then don't forget, what are we looking for? We are looking for days. All right, sorry guys, we have a couple more to do, and I know this is long. Okay, in 1619, Kepler discovered the relationship between the period T, the time it takes to complete one revolution of the sun, some science here, in Earth years of the planet and its average distance in millions of miles from the sun. Although at the only time the 6 inner planets were known, the formula correctly predicted the periods of other planets known at the time. Find the period of the planet Uranus with the average distance of 1,783 million miles from the sun. All right, let's look at what we have here. So first of all, guys, what we need to remember is that we are, we're gonna solve and then plug in at the very end, okay? I'm going to simplify this equation so then all we have to do is plug in, okay? Which means if we're finding the period, we're finding t. So I'm going to try to get t by itself and then do that. So we have log t equals 1.5 log d minus 2.95. Now, I have two variables, so I don't want to move all the logs on one side and put them together, because then I'm going to have too many variables together. So what I need to keep in mind is that when I get rid of this log and I do that base 10 here, okay, is I'm doing it that this becomes the whole exponent. Okay, so right now I have t equals 10. Now the other thing, what I'm going to do here, remember before how we were splitting it up because multiplying two bases told me to add the exponents, right? So when I saw adding of exponents, I could split it into multiplication. So I'm going to do that again. But then, of course, you see here subtraction, right? Well, remember, we can change subtraction into adding the opposite. Okay, so right now what happens is I get 10 to the 1.5 log d times 10 to the negative 2.95. Okay? Now, what does it mean when something or a coefficient is in front of log? Well, what that means is it becomes an exponent. So I have a log, or 10 log d of 1.5, or to the 1.5, times 10 to the negative 2.95. Well, what did we just do? What helped us out there? Well, you can see log and base 10 cancel. So now I'm given t equals d to the 1.5 times 10 to the negative 2.95. And now I have t isolated, where all I have to do is plug in d to my formula. So I have t equals, and we have the 1783 to the 1.5 times 10 to the negative 2.95. Now what's great is at no time did I estimate in the middle of a problem. So I know once I estimate at the very end, it is the closest it can ever get. Do not try to calculate with your calculator in the middle of a problem, guys. So when we plug this into our calculator, try it out now. You should get 84.47 years, right? Because we always have to put our units in. Two more. Okay. Oh, this one. Okay, a defrosted turkey at a temperature of 32 degrees Fahrenheit is placed in an oven of a constant temperature of 350. The temperature of the turkey after t hours is that formula where k is a constant. If after 2 hours, so if after t, the small t, if after it reaches the temperature, so this is the big T, find the constant K. So that's our first thing, is to find the K. Determine, then determine how long it will take for the turkey to reach the safe temperature of 172. So we have two parts here. First, we have to solve for K, and then we need to use it to find how long it will take to get that turkey nice and cooked. All right, so what we know is that in 2 hours, the temperature of the turkey reaches 125. And then let's plug in our normal equation here, well, the one they gave us. K we don't know, but we know that it took 2 hours to reach 125 degrees Fahrenheit. Now we're going to solve for K. Okay, you cannot, this is one of the biggest mistakes people make, guys. You cannot subtract 350 and 318 right now. Those are two unlike terms. So the only thing I can see to do is subtract both sides by 350. So we get negative 225 equals negative 318 e to the 2k. Now I have to divide both sides by negative 318. Again, I am not going to estimate or do any calculations until the last minute. Okay, how do you get rid of an e, guys? We ln both sides. I don't know why I did that. Hey, do you guys see it? What I made a mistake here? Because it's not ln 225 divided by 318. No, it's ln. So what I'm going to do is write my ln a little bit better too, so you guys can see. So I don't want you guys to make that mistake. This is ln all of it. So all of that's in parentheses. Does that make it more clear? So we get 2k. So what are we going to do? We're going to divide both sides by 2. Okay, which gives us k is approximately negative 0.173. All right. So now what? Well, now we have our equation, right? We have 350 minus 318 e to the k, which is negative 0.173 T is our turkey temperature. Okay. So what did we want our turkey temperature to be, guys? We wanted our turkey temperature to be 172. We're going to figure out how long it takes to do that. Guys, did you understand that this is where they come up with all the recipes where people are like, well, let's set it at this temperature for this long to get the perfect match. Now, of course, those of you who cook know that as you get closer to that recommended time, you always look at your oven and make sure everything's just the way you want it, okay? All right, back to math. Sorry, guys. All right, so let's solve for this. So I'm going to subtract 350 from each side to get negative 318 e to the negative 0.173 t equals negative 178. No, I'm not doing this in my head. I did this beforehand. Divide negative 0.173 t equals, I'm going to keep it as a fraction, so I'm not estimating in or rounding in the middle of a problem. All right, ln both sides, we get negative 0.173 t equals ln of 178, 318. Divide both sides, and we get t equals, or is approximately 3.35 hours. Nice, huh? Awesome. Turkeys usually take longer than that, but you'll understand when you have Thanksgiving and start cooking. All right, and it depends on how many pounds it is too. All right, here we go, one more. So we're going to talk about Newton's law of heating and cooling. So we're back to some science here. The number of students, N in hundreds. So I want you guys to keep that in mind. N is in hundreds. At Salt Lake Community College, who have acted on the rumor free popsicles in the library and received a free popsicle can be modeled by N of T, where T is greater than or equal to 0 is the number of days after June 4th, 2018. How many students got a free popsicle on June 4th, 2018? And how many days after will 4,200 students have picked up their free popsicle? Okay, so in other words, what we are solving for is June 4th. Well, June 4th is the initial day. So what we are going to do is substitute in 0 for t, to find out how many people on the initial day came in. So we have 84 all over 1 plus 2,799 e to the negative 0. Wait a second, we wouldn't put in negative 0, we would just put in 0. Now, if we did this out, what happens is it comes out to 3 out of 100. Now, remember though, this is in hundreds, okay? So that means 3 people had popsicles on June 4th. Okay, so remember it's in hundreds. So think of this if you want to look at it this way. This is 300. No, so I put thousands down. And we have to move it over because we're talking about in hundreds. So 3 people on that initial day came in. Now, of course, as people get free popsicles, word spreads and more people come in to eat popsicles, right, guys? I mean, that's what we always know. So what we want to do is, after the rumor is spread, how many days will it take for 4,200 students to have picked it up? Well, first of all, we know that the equation is 84 over 1 plus 2,799 e to the negative t. Now, we want to know when 4,200 students, but remember, n is in hundreds. So how many hundreds are in 4,200? 42 are. Okay, so you only need to do 42 because it's in 100. Okay, let's do some math. I don't like the fractions, so let's get rid of it. 84 equals 42 times 1 plus 2,799 e to the negative t. Okay, there's a multiplication there, so I can divide. And then we have, so that's 2 equals 1 plus 2,799 e to the negative t. You cannot subtract here, right? Because there's a multiplication there, and these are unlike terms. So we must subtract 1 from both sides. We get 1 equals 2,799 e to the negative t. Sorry, guys, I'm laughing at myself for saying this so many times. Divide. We get 1 over 2,799 equals e to the negative t. How do you get rid of e? We ln both sides. Equals negative t. And then don't forget, we have to divide both sides by negative because we want t, not negative t. But when you do that, we get t is approximately 7.937. So about 8 days, right? So this rumor spread, people found out it was true, no longer a rumor, and it only took 8 days to get out popsicles to 4,200 students. All right, guys, there we go. Make sure you focus on what information is given to you, what the question is asking for, and remember what formula to use.